I do lead both operations and technology, so you could say I sort of wear two hats, manufacturing and development, R&D. Most of the history, my history, has been in R&D, but I do have the privilege of also leading a very talented, excellent operations team here. And I want to tell you a little bit about both of those items. So first of all, I think it's been covered. I think you've heard a lot about this. But gallium nitride, silicon carbide, what are they? They are the best wide bandgap power semiconductor technologies out there in the world today. Who cares? What's great about wide bandgap? Well, the wide bandgap enables the semiconductor to withstand extremely high electric fields, especially when you're talking about 600 volt, 1200 volt and higher devices. That's really critical because you can make a lot smaller chips to handle the same amount of power with a wide bandgap semiconductor than you can with silicon. So it's about 10 times higher electric field you can withstand with both of these technologies, roughly speaking. And as a result, a lot of things shrink. The chip shrinks, the capacitance shrinks, it can operate at higher frequencies. GaN especially is basically an RF technology that we've repurposed for a power technology, so it can switch incredibly fast. Not gigahertz for power, but well up into megahertz and even tens of megahertz if you so choose. That's largely because it can switch 20 times faster or more with a very extremely low input capacitance. Everything with both of these technologies can shrink. It can be 3 times smaller, lighter, and charge things 3 times faster. And with the development of the technologies and the cost improvements we've been putting in and will continue to put in over time, and with the benefits of our system expertise, we can lower the system cost substantially as well. All of that while saving energy. And really, if you look at it, that may be our primary motivation, that we are really, as a company, trying to improve the energy efficiency of electrical applications and move from non-electrified to electrified applications, making it all cleaner, safer, and more efficient and less polluting. So speaking of that, our mission in the company is to accelerate sustainability. These are some metrics that we're following. On the upper left over here, we have our corporate goal for greenhouse gas scope 2 and scope 3 emissions. What does that mean? It's everything that we're doing here, the lights, the energy in this building, plus what we do in manufacturing. All of what our manufacturing partners put into our products are included in those scope 2 and 3 emissions. Our goal is to, as we manufacture our products, continue to make those manufacturing processes better and reduce the amount of scope 3 emissions in each of our products. Now that we're not just a GaN company, we're also GaN and silicon carbide for one complete year. We have a higher target to see a 10% down reduction in the amount of greenhouse gases emitted in the combined manufacturing of both GaN and SiC. I think that tells part of the story. Yes, in making our products, we do emit greenhouse gases. But if you look over to the right, there are 2 charts, one for GaN fast technology, one for GeneSiC technology. You see the arrows pointing upwards on the left. First of all, in the GaN, you see that there's a black arrow. That's silicon. That's how much greenhouse gas is emitted in making a silicon device equivalent to our GaN device. You can see the GaN device has a blue arrow pointing up. That's much smaller. It takes much less greenhouse gas emissions to make a GaN transistor because they're much smaller and the process is actually simpler than a silicon superjunction device. That would be comparable. But you see the large blue arrows, which add up to the large green arrow, which is the customer needs far less materials in magnetics and heat sinks and filters and capacitors and everything to use our parts because they can operate at high frequency. So that benefit is quantified in terms of less greenhouse gas emissions and all of those materials. And then on top of that, with our increased efficiency, we need less electricity, which has to be sourced and usually is sourced from fossil fuels, hopefully not in the future, but now. So there's some emissions associated with that. So all of that adds up to a much larger impact positively to the planet of using our product than it takes to make the product. So we save 4 kilograms of CO2 for every GaN device. We see the same thing over here with GeneSiC, a small positive arrow up, but the negative arrow on green, we save 25 kilograms of CO2 for every silicon carbide part we ship. It's a great motivation to ship as much as possible, right? We're going to save the greenhouse gas emissions, the more we can ship, and that's what we want to do. We've also been recognized as a leader in sustainability by ESG Investing, and we have been certified as carbon neutral. The little bit of up arrows that you see in the manufacturing of our products, we've offset with carbon credits. So let's talk about the market opportunity. This is a pretty busy graphic that shows you a lot of applications for our products, and you can see that there are many. And therefore, you can understand why there's a $22 billion market that, as Gene described, is expected to grow substantially over time. In this corner, you have applications that are clearly going to be GaN. Those are the ones that are in the 650 volt range, and also GaN also has some capabilities in the 100 volt range. But many applications are in the 650 volt range because everything that you plug into the wall needs a 650 volt device to control the power coming out of the wall. So that's a lot of things. It includes adapters. You see many of those around, how we've improved the efficiency of those and shrunk the size by factors of 3 and 4 in some cases. Smartphone and tablet chargers, laptop adapters. You'll see a display of a very thin TV that can now be realized because of wide-bandgap technology with extremely thin power supplies, less than 10 millimeters in thickness. Home appliances, a very big market for us. New products that we have in GaN for motor drives we'll talk about. And then we have a region of overlap. Again, this is 650 volts, but as you get up into the higher power levels, you can say both GaN and silicon carbide are relevant in that space, and in some cases may compete with each other. In other cases, they're just complementary. We'll use an ideally, one socket is ideally suited for the use of silicon carbide, another for the use of GaN in the same application. For example, in OBCs. We have other applications like residential solar, data centers, both the UPS and the power supply unit in data centers. And we are actively promoting both GaN and SiC technologies and working with our customers to find the optimum solution. The great thing about our company is we have both. Not many companies, in fact, I don't think any other company, can say they have the leading technology, the best performing devices in both of those two technologies. Not only that, we don't have to be distracted by making silicon devices, so we're completely focused on it. Then you see in silicon carbide, and we have the chart going out to 6,500 volts. Actually, our friends from GeneSiC, their expertise doesn't stop there. They've made parts, I think, up to 15,000. They know how to do it. There's a very deep level of expertise that we have in-house on how to make high voltage devices, and silicon carbide is the technology that really is the right technology for 1,200 to 6,500 volt range devices. And you see some of the big applications, of course, the electric vehicle powertrain, especially the 800 volt battery bus technology for EVs, which is the most efficient one for higher power EVs. Industrial drives and robotics, also very key. Commercial solar, 1,700 volts is a popular range, even maybe a little higher, up into the 2,000s. Wind, 3,300, going up towards 6,500. Rail, also 6,500. So we have the technologies to address this incredibly wide range of applications, and we're looking forward to doing so. This is our supply chain as it exists today. The supply chain is growing and evolving. We're bringing on new partners as we expand our portfolio. When you talk about chip manufacturing, it starts with, of course, the wafer, either the silicon wafer or the silicon carbide substrate. Right now, both of them are 6-inch substrates. We put epi on both, GaN epi and silicon carbide epi. We have suppliers for both of those services. The silicon carbide epi is a foray that we're making into manufacturing. It is, we're bringing in, and as Gene alluded to, in this very building, we're going to be putting epi reactors in. We have a world-class expert in silicon carbide epi that we've brought onto the team. He's going to enable this. He's done it multiple times in the past. This will help us with lowering the cost of our supply chain as we bring these technology in-house. And then we have our partners TSMC and X-FAB. X-FAB is in Texas, TSMC in Hsinchu in Taiwan. And they're great partners. They put in all the capacity that we need and will continue to support us. We have agreements that will continue to take us into the higher volumes that we need for our growth. That being said, there are many other companies that are interested in doing business with us, and we are investigating other options as well. On the wafer front, on the assembly side, we have multiple partners through several countries in Asia, notably Taiwan, Philippines, Thailand, and China. And we are working with those and achieving the results that we want to see. From the beginning of our company, it's been a focus, as with most startups, but we particularly paid a lot of attention knowing that in gallium nitride, there really was sort of an open opportunity to integrate and to protect the inventions of our company. We developed over time a significant portfolio, over 250 patents. If you look at what we developed for the GaN technology, but what we've also acquired through GeneSiC with their advanced silicon carbide device and process IP, also Elevation with controller IP, and also VDD Tech with isolator IP. Leading edge IP in all cases. We've really built up our portfolio of patents, and I would say it would be very hard to be a player in the field of GaN power integrated circuits without taking notice of this portfolio. So we do have proprietary designs and processes. A lot of the effort that we spent over the last several years has been building up a unique and proprietary process design kit. This means you have all the models, you have all the transistor designs, the component designs to build power ICs with. It's completely in-house. We overlaid it over the TSMC process, but no one else has access to it except our company. And as a result, we've been able to develop what I'll show you, some of the world's most advanced, probably the most advanced GaN power ICs that you'll see in the world. We've also had a tremendous rate of innovation. We are on generation 4 technology, both in GaN and SiC. We are planning future generations that are in development, and our goal is to release a new generation every 12 to 18 months. So speaking of generations, this is an evolution of the generation of products, starting with old, slow, and inefficient silicon, which we started by developing a device together with TSMC to replace silicon and to be, as I said, much smaller chips, much faster chips, but a little vulnerable on the input side. It's an enhancement mode gate. It should be driven at about 6 volts. If you overdrive it or don't do it carefully, you can overstress the device and run into reliability problems or failure. So what we recognized early on is that we should integrate. And that's how we developed all that IP around the integration, starting with the very first year of our company and developing over the last 8 or 9 years to improve and build upon our IP portfolio. The next step that we took and introduced to the market, we called it was our 3rd generation of product, GaNSense. We noticed that all of our customers are using inefficient sense resistors in the current path, in the main current path, to feed back to the controllers. And there was as much voltage being wasted and dropped and dissipated in the resistors as there was in the devices. That seemed very nonsensical to us. So we introduced this product called GaNSense. So we provide current sense feedback. We take that signal from just a tiny little piece of the current that's flowing in the device and losslessly, without power loss, send that signal to the integrated circuit portion. We do signal processing to improve the accuracy of it, and we send it back to the customer so they can have a good signal to trace the operation of the device. But in addition to that, we can provide protection features. So if it goes too high in current, or if all of a sudden a short circuit comes along, we can turn off the device before damage. And the controller can respond to protect the overall system. We added also the features of over temperature protection. In case it goes over the rated 150 degrees C, the system will react and protect itself. It's immune to ESD, human body model, up to 2,000 volts. And it has autonomous standby mode if it's not being used to reduce the quiescent current and the standby losses of the chip. We then introduced this. We went from a single device into a half-bridge device. And that's one of the big things we're talking about today. The half-bridge is a building block of most of the power electronic circuits in the world. And this one is widely already in use. The very first version of this has been sold in multi-millions of quantities, but we've now built out a whole portfolio that we're talking to you about today. And finally, GaNSense control. With elevation, we brought in the control techniques for a quasi-resonant flyback converter. We've got that controller now in the same package. We can sell you just the controller, but we can put it with a GaN chip and give you a fantastic solution for advanced high-density power adapters. So here's a bit more about the half-bridge. We're very excited about this product. We actually started working on the half-bridge from the very early days, knowing that it was critical. We've got a tremendous amount of IP around an integrated GaN half-bridge. Lots of different patents and different ways in how to do that. It includes that lossless current sensing feature. It's got all these attributes. The circuit is very small. You can see it uses much fewer components around it. That's all been, the functionality of that has all been brought into this very tiny 6 millimeter by 8 millimeter package, probably smaller than your little finger nail. And we can deliver hundreds of watts of power with this thing in motor controls and in power converters. So it has all those attributes that we discussed already about GaNSense technology. So this is a little bit about GaNSense control technology. With power adapters and with electronic applications in general, if they're less than 65 watts, you don't have to worry about the application causing disturbances on the grid. Even if you have many, many of these adapters, they don't worry too much. The regulatory environment is such that they say, I'm not going to worry about you distorting the waveforms on the grid with your 50 watt or 25 watt adapter. But when you get over 65 watts, the regulatory environment says you have to have power factor correction. So we are also working on power factor correction solutions. And the adapters that are over 75 and 100 and 200 and 300 watts all have both PFC and DC to DC elements to them. And this is a great application for our single GaNSense devices and our half-bridge GaNSense devices, as well as our quasi-resonant and synchronous rectification controllers that we put into the less than 65 watt category. So, and we do that, as I mentioned before, the COPAC, which is a GaNSense control COPAC, controller plus GaN. So I wanted to spend a little time, and I really only focus on this in this one slide, but this deserves more than one slide, probably a whole seminar. But we are introducing a technology that will really change the game in a lot of applications. And I've listed a few of those applications. Some of those are PFC applications, some of those are converter applications, some of them are inverters, some of them are motor drives. This technology can have a major impact on many of those. What is it? If you look on the lower right, most systems take wall energy, convert it to a DC bus. There's a big caps associated with storing the energy, And then they take that energy and they convert it back to some sort of an AC waveform, some sort of a switching waveform. Could be low frequency like motor drives, could be high frequency like converters, but there's 2 stages in that process. And I just described that a couple of minutes ago. If you have this bidirectional switch, you only need 1 stage. And therefore, your losses can be cut dramatically down, and the number of components that you use in your system can be cut dramatically down. Not only that, in semiconductors, we always want to make things smaller, right? We want to pack more things on a chip. If it's digital, you want to go from thousands to millions to billions of transistors on a chip. If it's power, you just want to get more amps and volts and watts out of a chip. So this is sort of a scale representation of if you were going to do this with superjunction silicon, make a switch of a given on resistance, it would be represented by those 2 red squares. And if you were going to do it with a standard unidirectional GaN device, it would be those 2 green squares. Obviously, you can see GaN chips to do the same job in silicon are much smaller. We talked about that earlier. But if you need a bidirectional switch, instead of putting 2 devices in series to block voltage positive or negative, like you normally have to do today, you just have 1 device. So you take that green amount of GaN and make it dark green, tiny little bidirectional GaN chip. So up to 9 times less material than is used in the silicon solution. Can be even higher, and we're seeing tremendous interest in this technology. I think it's going to be a game changer, and I think you'll hear a lot more about that as next year goes on and we roll this out to the market. And so Gene mentioned this. It's a tremendous, exciting thing for us for the near term. This is our entry into high-power GaN. Many customers are looking at this in the data center, solar, and EV application space. It has all the attributes that I mentioned on the GaNSense technology. It's GaNSafe, so it adds this extra attribute of high-speed short-circuit protection, which you need for high-power systems. What we call easy EMI. This device can be tailored to run and operate in a very quiet mode, not causing distortion, not causing noise, not interfering with other devices around it. And the packaging that we're putting this thing we call easy cooling. These are higher power packages with very low thermal resistance to the cooling system of the environment. They're very robust. They have transient capability up to 800 volts. You're going to hear a lot more about that today. So I'll leave it at that. And then just mention this critical part of our portfolio, this major part of our company now, GeneSiC technology. You're going to hear a lot about it. You see the key packages there that we're offering today. You see the range of our products up to 6.5 kV as we discussed. They're very robust. They're very fast. They operate much more cooler. Is that a word? More cooler? Cooler, much cooler than the competition. And you can parallel these devices. They are rugged devices. I'm so excited about this technology.